Okay, hello students again. So we are now in our quarter 3 week 6 and the topic is relationships of exterior and interior angles of a convex polygon. So our objectives at the end of the video you should be able to derive inductively the relationship of exterior and interior angles of a convex polygon. And number two, compute the sum of interior angles and sum of exterior angles of an n-sided polygon. So please like, share, and subscribe to Ma'am Desma Tutorials. Hit the notification bell button to alert you of the latest video lessons. For all questions, comments, and suggestions, please put them down in the comment section below. So let's start from a review. Direction. Refer to the figure below and identify what part of the polygon are the following. Choose your answer in the box. Okay, first, point A. So from the figure at the left, look for point A. And then what do you call this? Okay, it's called vertex. For number 2, line segment AB. From the figure again, look for the line segment AB. What do you think what part of this polygon is? Now it is side. Number 3, angle ACD. Here is angle ACD. Again, what part of this polygon is angle ACD? Okay, so we have interior angle. Number 4, angle CDA. CDA. So, again, what part of the polygon is this? Okay, exterior angle. Number 5. For number 5, it is AD or line segment AD. Okay, so we have diagonal. Okay, now next. For the next activity, state whether it is a convex or concave polygon. For number 1, concave. Number 2, concave again. Number 3, it's convex. Number 4, convex. Number 5, concave. Okay, now next. For this review, identify now the types of polygon in the picture. So based on its sides. So count the number of sides and then tell the types of polygon in the picture. Okay, for number 1, we have quadrilateral since it has 4 sides. Number 2, it is a pentagon. So pentagon, 5 sides polygon. Number 3, it is a triangle. So we have 3 sides. Number 4, hexagon. Hexagon, as we all know, there are 6 sides in a hexagon. And the last, number 5, we have quadrilaterals. Okay? So, let's proceed now to our lesson. Interior angles of a convex polygon. From our previous lesson, we study already what do you mean by interior angles of a convex polygon. Okay, so interior angles are angles found inside any polygon. These angles are formed by the interior intersection of 2 sides of the polygon. In the given example at the right, look at the triangle. Angle M, angle N, and angle P are the interior angles of triangle MNP. Polygons are made up of several triangles. You can divide a polygon into triangles by drawing diagonals. So as you can see from this figure. For example, A quadrilateral can be divided into two triangles, and a pentagon can be divided into three triangles. So look at this figure. Okay, so this one, from a fixed vertex, we draw diagonals. Okay, so one diagonal for quadrilateral. For the next figure, which is pentagon, we draw uh, two diagonals, and therefore it forms three triangles. Okay, next. Consider each convex polygon with all possible diagonals drawn from one vertex. By doing this, you can actually form triangles within each polygon. So complete the table below by writing down the number of sides and the number of triangles formed from the given polygons. Again, complete the table below by writing down the number of sides and the number of triangles formed from the given below. You can pause the video and then answer the given activity. Okay, so now given the name of polygon, then the illustrations, and then find out the number of sides, and the number of sides represent as n, and the number of triangles formed represent as n minus 2. So the number of sides subtract by 2 to find the number of triangles formed. Okay, for the triangle. In a triangle, we have three sides, and therefore, how many triangles formed? Okay, it's 1. For the quadrilateral, in quadrilateral, number of sides are 4. Number of triangles formed, we have 4 minus 2 is 2. Next, for a pentagon, in a pentagon, how many sides? Okay, 5. Next, number of triangles formed in a pentagon. If you subtract 2 from 5, so you will get 3. For a hexagon, how many sides are there in a hexagon? Okay, 6. And number of triangles formed, if we have 6 minus 2, okay, 4. Okay, for the next one, we have the heptagon. How many sides? Okay, 7. And the number of triangles formed, if we subtract 2 from 7, so we will have 5. For the octagon, how many sides are there in an octagon? We have 8. Okay, subtract it by 2. So we will have that the number of triangles formed, we have 6. Okay, so as you can observe in the table, the sum of the interior angles of a polygon is equal to 180 times the number of triangles that can be drawn from one vertex of the polygon. Furthermore, notice that the number of triangles that can be drawn from a polygon is 2 less than the number of sides. Okay, so now look at the table. Given again the polygon, the number of sides, number of triangles formed, and the sum of the interior angles. Okay, for a triangle, we have 3 sides, 1 triangle, and therefore the sum of the interior angles is 180. For a quadrilateral, number of sides is 4, number of triangles formed, so just multiply 2 by 180, and the sum of the interior angles of a quadrilateral is 360 degrees. Okay, for a pentagon with 5 sides, number of triangles formed, we have 3, so 3 times 180 is equal to 540 degrees. 540 degrees is the sum of the interior angles of a pentagon. Okay, now for the hexagon. Hexagon has 6 sides. Number of triangles formed, we have 4. And then 4 multiplied by 180 is equal to 720. By the way, so why 180? Okay, so since we said a while ago that the sum of the interior angles of a triangle is 180, di ba? And then we have four triangles formed. So that's why you multiply it by 180. And our answer for the hexagon, sum of the interior angles of the hexagon is 720 degrees. Okay, now, so therefore, to find the sum of the interior angles of a polygon, we can use this formula. Okay, S of n is for the number of sides. So quantity of n minus 2 times 180 degrees. So the sum of the interior angles of a polygon with n sides. Okay, and then n, the number of sides of the polygon. Okay, let us have the examples. Number 1, find the sum of the interior angles of the following polygons. For letter A, so let us find the sum of the interior angles of the heptagon. Let us use n as 7 since heptagon have 7 sides. So S of n is equals to the quantity of n minus 2 equals 180 degrees. So substitute n by 7. So it becomes quantity of 7 minus 2 is equal times 180 degrees. So we have 5, then times 180 degrees, the answer is 900 degrees. So the sum of the interior angles of a heptagon is 900 degrees. Okay, for example B, an octagon. An octagon has 8 sides. So substitute to the formula. So S of n is equal to quantity of n minus 2 times 180. So 8 minus 2 times 180. So 6 times 180 degrees. The answer is 1080 degrees. Thus, the sum of the interior angles of an octagon is 1080 degrees. For number 2, to find the measure of each interior angle of a regular polygon, divide the sum of the interior angles by the number of the sides of the irregular polygon you wish to know. Formula. S of n is equal to times n minus 2 times 180 degrees divided by n. Example. The sum of the interior angles of a square is 360 degrees and it has 4 sides. What is the measure of each interior angles? Okay, so again, here's the formula for finding the sum of the interior angles. So 360 divided by 4, so we have 90 degrees. And therefore, the measure of each interior angle of a square is 90 degrees. For letter B, the sum of the interior angles of a pentagon is 540 degrees and it has 5 sides. Find the measure of each interior angle. So again, look at the solution in finding the sum of the interior angle. So 540, then divide it by 5. So the answer is 108 degrees. And the measure of each interior angle of a pentagon is 108 degrees. For number 3, to find the measure of an unknown interior angle of any polygon, find the difference of the sum of the interior angles of the polygon and the sum of the given angles. Okay, so we know that the triangle or the sum of the interior angles of a triangle is 180 degrees. So therefore, missing this angle P. So from the figure, you can have 68 degrees, 52 degrees, and unknown angle P. So, to get the measure of angle P, subtract 180 degrees by the sum of 52 and 68. So, we will have 180 minus 120. And therefore, your answer is 60 degrees. Okay? So, angle P is equal to 60 degrees. For number 3, to find the measure of an unknown interior angle of any polygon, again, find the difference of the sum of the interior angles of the polygon and the sum of the given angles. Okay? So, as you can see, we have quadrilaterals here. And remember that the sum of the interior angles of quadrilateral is 360 degrees. So, therefore, to find the measure of angle S, so get first the sum of the three given measure of angles of interior angles and then subtract it from 360. So get the sum of 63 plus 85 plus 102. So we come up with 250 degrees and then subtract it. So angle S is equal to 110 degrees. The next one again, number 3. So we have letter C, a pentagon. Okay, in a pentagon, the sum of the interior angles is 540 degrees. So again, get the total of the given measure of interior angles. So we have 75, 150, and then 90. Okay, 90 plus 90. Why 90? Okay, as you can see from the figure, we have the marks. Ayan. So, si angle M with marks, angle R with marks, and then it refers to 90 degrees. Okay, which means they are right angles. So, that's why I put 90 plus 90 here. Okay, so again, so add 75, 150, 90, and 90. So 540 degrees minus 405. Angle C is 110. Okay? Okay, for the next example, as you can see from the figure, it is a pentagon. The sum of the interior angles of a pentagon is 540 degrees. So, to find the unknown angle, which is angle C, you have to subtract the total of the given measure of interior angles from 540 degrees. Okay, so we will have 540 degrees minus the quantity of 75 plus 150 plus 90 plus 90. So we have 405. Okay, so I wrote 90, 90 because as you can see from the figure, there is a mark of a right angle in angle M and angle R. So 540 degrees minus 405 degrees, the answer for angle C is 135 degrees. Okay, now, so let us have this. Let us do this problem. Let us solve this problem. Okay, for number 1. Find the sum of the interior angles of a regular hexagon. Okay, so as we all know, in a regular hexagon, so we'll have n is equals to 6. Okay, and then let us have our formula. Quantity of n minus 2 times 180 degrees. Okay, so we will have 6 minus 2 times 180 degrees. So we will have 4 times 180 degrees. So our answer is 720 degrees. Okay, so the sum of the interior angles of a regular hexagon is 720 degrees. Okay, next one. Number 2. If a polygon is divided into 8 triangles, what is the sum of the interior angles of the polygon? Okay, so since given now 8 triangles, so as we know, this n minus 2 is the number of triangles. Okay, now, so which is 8. So what you're going to do is just get the product of 8 and then 180 degrees. Okay, so we will have 8 times 180 degrees. So the answer is 1,440 degrees. Okay? And this 1,440 degrees is the sum of the interior angles of a decagon. So 10 sides minus 2 is 8. Okay, 8 triangles. So again, 1,440 is the sum of the interior angles of a decagon. Next, number 3. If the measure of the first two interior angles of a triangle are 44 degrees and 107 degrees respectively, what is the measure of the third angle? Okay, so for this problem, you have to remember that the sum of the interior angles of a triangle is 180 degrees. Okay, so you have to subtract the total of 44 degrees and 107 degrees from 180. Okay, so bring down 180 degrees, get the total of 44 and 107. So we will have 151 degrees. And then subtract it now. So our answer is 29 degrees. And this 29 degrees is our third angle. Okay. So again, 29 degrees is our third angle.